Talking about is multi-everything. You've probably heard multi-threading, multi-processing, multi-computing, multi-programming. All of these things are concepts that get thrown around and confused and mixed up. Tiago, maybe 3 years ago, gave a briefer talk with all of the content of the talk that I'm about to give, talking about some of these ideas and sort of how you can think about them. Two major simple ideas in the world of multi-thinging. There's concurrency and parallelism. They are not the same. They're very different, both pretty simple, can be separate, can be together. I'm going to define them as concurrency when independent jobs, tasks, programs, whatever you want to do, can all make progress regardless of the status of any individual job. Does that make sense? So you have lots of jobs all making progress regardless of the status of any individual job. Something that is not concurrent is if you do one job and then another job and then another job. Doesn't say anything about when those jobs are making progress. Make sense? Parallelism, really simple. Doing multiple things at the exact same time. Different but related. Lots of things, especially in computing, because the time frames are so short, seem to be parallel, but they are not. But you can get actual parallelism, which I will talk about. Good so far? Pretty straightforward, major but simple ideas. So I'm going to talk about these ideas through a bunch of different lenses. Single functions, multiple functions. I'm going to talk about gevent. I'm going to talk about threading, multi-threading in Python. I'll talk about threading in other languages, which I assume C or C++ is an example of one of those languages, but I don't actually know. I'll talk about multiple processes, or multi-processing, if you want to call it that. I'll talk about multiple processes with concurrent programming ideas. And I will talk about what we do a lot of, which is multiple systems. I don't know what the right term you want to call that, distributed systems, whatever. But these are all different things which may or may not include any of these things as a many-to-many relationship, which I'm going to try to plow through one of the most important things in the world, especially to me, and that is fishing. We'll talk about all of this with a fantastic fishing analogy. The goal is to catch fish.
Andrew's standing up to walk out.
No, he's been freezed. The goal when you're fishing, or a goal when you're fishing, is to catch fish. Lots of other goals. Robert Traver, that's the pen name of John Volcker, who was a Michigan Supreme Court Justice, county attorney, prosecuting attorney, a famed naturalist, and a favorite author of mine. He writes sort of drunk hick versions of Hemingway or Thoreau, if you will. He says, "I fish not because I regard it terribly important, but because I suspect that so many of the other concerns of men are equally unimportant." So I'll leave that quote with you guys as we talk about fishing. All right, so fishing. Let's imagine you have a boat. You've got me fishing, and yes, this is great. I have a sailboat stick figures on mine, but it's not as good. Perfect.
Turn the black pen.
Yeah, me there.
Yeah.
Yeah, here.
In case of the dark.
You vote.
When you're fishing, in this particular case, perfect. You got your boat, you got me, you got a rod with a line, and on the end of it is a worm. Perfect. Yeah, all the way down, perfect. You will need some fish at the yeah. Awesome. Awesome, some fish down there, great. Great. And you're going to need a variety of resources while you're fishing. In my case, that's a cooler with B&Js and beer. Set that under the boat. Awesome. Great. Great. All right. Very simple fishing setup. You have myself. I can actually label these. That'll work best. I'm going to say that I'm the processor, or some sort of processing unit. You've got some function that I'm doing, which is fishing with a worm. That's whatever. I've got some like system resources. These need to be happy for the whole system to work correctly. And that's basically it. Really straightforward. It's me doing a single function. Any concurrency. Sorry, the worm, here's how you fish if you guys don't know. You cast it out, you wait for it to sink, you wait for a fish to bite, and then you reel it in. That's all you do. So that's basically what I'm doing right here. Single function, cast the worm out, wait for it to sink, wait for it to bite, reel the fish in. Make sense? Any concurrency? Any parallelism?
No.
Steve has Steve face.
No.
Fishing, right?
What?
Our only functions are fishing.
Can you drink a beer and not drink it?
So that's not
Drinking's not a
that's
function.
okay.
Drinking is sort of this process that's going on at all times. All right, so a single function. What's the problem with this setup?
You can only catch one fish at a time.
Exactly, not enough fish. Not enough fish. All right, so first thing I would do, make sure I got through all my things here. Yes, first thing I would do is try another style of fishing, right? So I could add, maybe I'm going to fish with, instead of a worm, I'm going to fish with a bobber and a minnow. That'd be like another function. I could run that function, totally running this one as a single function. Or I could fish with fly fishing setup and cast flies out there and try and catch fish. So that'd be a little bit better. I would have multiple functions. But if I'm only fishing with the worm and then I stop and my minnow and then I stop and I fish with my fly fishing rig, still no concurrency, no parallelism, just working with multiple functions, multiple ways to get the problem solved.
You fish with like a net?
If you want to draw a net as one of my fishing options, that'd be fantastic. But if this is me, what I would be doing is actually setting up all of those ways to catch fish and then running back and forth between them as many fish as possible. So I would have my worm, I draw another line with like the bobber sitting there with a minnow on the bottom, and then maybe while those are just sitting there, I'm sitting in the middle and trying to catch fish down at the bottom. Yeah, perfect. This is starting to be an effective. So let's talk about what's going on here. Any concurrency?
Yes.
Why do I have concurrency?
You're setting this one up with a bobber,
Yep,
then you're casting this,
yep.
and then you're grabbing your net and swinging around wildly, looking to see if occasionally if any of the other ones. do it.
Exactly. I've got multiple independent jobs going. Net fishing, bobber fishing, worm fishing, all making progress. Most of them are just sitting there waiting, but making progress. That's an important part of the fishing process, regardless of the status of any individual job.
Wait, that last part's not true, right? Because if all three of them had something happen on them, it would matter that something was happening because you can't do it.
Yes, but they can still make progress. Not saying that they're going to always continually make progress,
Oh.
but they all made some amount of progress before they had to stop and wait for a resource or a processor to come help them out.
What if you only had 3 nets? What's that?
Unless I can swing all 3 nets at the same time,
That's multiple functions.
that would just be sort of, I have multiple ways to solve this problem. If I could swing all 3 nets at the same time, that might actually just be parallel versus sort of concurrent approaches to this problem. So yes, we have concurrency, still no parallelism. I can't actually do all 3 of these things at the exact same time, or any 2 of them at the exact same time. This is like gevent in Python. If you haven't used gevent, it's basically this process. You do 3 different things until you have to wait on one of them, and then you switch to the next thing and start doing that. There's only one processor ever working. It's not, and nothing is happening at the exact same time. But this is a more efficient way to catch fish, given one resource, which is me, the processor. Pros and cons. Doesn't require more processing resources. It's just me. It's the same 3 rods that we had in multiple functions. Same amount of beer, same amount of sandwiches. No additional resources to get this done. Since a lot of fishing is just waiting, again, these are all 3 making progress right now. So I'm doing, work is getting done even though it's the same amount of processing. It's more efficient. It is better. What are the problems with this? Definitely some cons.
If you catch fish, what do you do?
Yes, if I have 2 fish on at the same time, it's just me. I'm then a bottleneck in the process. I can't actually do work across 2 of these rods at the same time. That's a problem.
So that's the problem, but that would be the same problem on multiple functions.
Yep, that would be the same problem with functions. Big problem with this approach, and I have tried it, is it's very difficult to manage. It's tricky to understand and get all of these systems working correctly. What you end up with is like the minnow has swum over and wrapped its line around the worm, and you didn't realize that would happen, and it's very just like tricky to manage. It's the same problem with something like gevent or multi-threading. You have all of these resources in the same location, all able to interact with one another, and it's just very difficult to figure out exactly what is going on at any particular time. Good so far? Great. Quick side note on, I'm going to talk really quick about multi-threading in Python and multi-threading in Python and C++. When you use multiple threads in Python, and a thread is basically, you can think of it as a sub-process for your process. Not technical definition, but that's one way to think about it. When you use multi-threading in Python on a single processor, it's very, very, very similar to the way gevent works, where it's running one set of commands. When it has something that has to wait on, some I/O, something like that, it'll switch to another command, and so on and so forth. You will never actually run anything parallel at the exact same time when you're using multi-threading in Python on a single processor. On a multi-processor or multi-core system with multiple threads, you could actually end up with something happening at the exact same time, except in Python. Python has a global interpreter lock, which basically means that the interpreter will only execute on one particular thread at any time, no matter how many processors or cores that you have running. So threading in Python is like if I took my little cousin out fishing who's like 10 years old. Theoretically, she could do some of the work, but anytime she does have to do the work, I would have to like stop and watch her and help her put the worm on and like make sure nothing goes wrong while she's doing it. It wouldn't actually speed up anything. In fact, it might slow me down because I'd have to stop doing what I'm doing to go help her do little pieces of fishing. So multi-threading in Python isn't that great even on multiple cores, which is largely why I think things like gevent exist, where they try to simplify a lot of that. Some of the differences, the threading is actually an OS controlled task, so when it switches and stuff like that is not really under your control. Gevent, I'm not sure what it's written in, but it's a lot more user-friendly in terms of controlling when things get switched and how you switch from different processes or different threads that you're working on.
So parallelism is actually doing multiple things at the exact same time, not the ability to do multiple things at the exact
Is
same time.
actually doing multiple things at the exact same time, which needs the ability to do, right?
Right, but if it's a tiny bit off just because of whatever, even if it could have been at the same time, it is
Yeah.
not parallelism.
Generally, if it could have been at the exact same time, you're never really going to tell whether it was or was not at the exact same time. So the ability to do something at the exact same time is pretty good for parallelism, is in my personal opinion, which is not at all necessarily correct. Great. So threading in Python is sort of kind of weird, not that exciting for us in this particular talk. Threading in something like C or C++, where there is no global interpreter lock, and you have multiple ways to process, is the next scenario that I'm going to talk about. If we want to add more processes to this model, what do we have to do? Add more people to the boat. That's how we're going to start catching more fish at this point. So a multi-threading example, as we make our boat bigger, would be if I took my wife, Kara, fishing with me. Why is Kara a good example for multi-threading in something like C or C++? She's really good at worm and bobber fishing, so she can, fish semi-effectively. She's not going to consume a ton of my beer or sandwiches. She's pretty small. She doesn't prefer beer most of the time. PB&J is pretty low on her quality of food scale, or whatever. So that's actually pretty similar to multi-threading relative to some of the other things we could be doing. Pros of that, she's also not going to bring any of her own gear. I buy most of the fishing gear in our household. She doesn't own any of it, so she's going to end up sharing all of the stuff that I've already brought to this party. Yeah, this is so much better than I would have been able to do. So, pros of multi-threading in this particular situation. She's sharing all of my resources. That's usually pretty good. She's not going to consume a ton of extra operating system or system resources. And we're going to get actual parallel work done in this case. Multi-threading with multiple processors. If I have a fish in my net and I'm scooping it out, she can catch a fish on the worm and the bobber and do the processing work to reel that thing in. And we're going to get more done, catch more fish, following this analogy. Questions so far?
So in Python, you have multiple processors, but you can't run multiple things.
You don't get to run things in parallel.
You need multiple processors to run things in parallel.
Yes.
You cannot have one processor run things in parallel.
No.
Got it.
If you have one processor that can only do one thing, it's not going to be in parallel. It's going to look pretty parallel, but it's just jobs getting worked on concurrently.
To be clear, for Python, if you looked at your tasks running, when it says Python, that is the process. Not that if you in another terminal shell started your own second Python process.
Sorry. Yes.
They don't communicate like that. But this is in the sense that there are C++ programs where you just run that one command, but it actually uses multiple processes and threads. In this case, we're assuming that you're not running multiple terminals with different commands. This is separate.
What are some of the cons of this situation? One of the pros was we're using all the same stuff together. That's also a con. Kara would be using my worms and my minnows. If she leaves the worms in the sun, they're going to fry and bake, and both of us are not going to have any worms. The things she messes up, where she casts her line, stuff like that, could mess up my fishing. So this is also semi-tricky, somewhat complicated, and we have to be careful because we're basically operating with the exact same set of resources. This is how it works when you're running multi-threading. Your thread is a sub-process of your parent process, sharing the same memory within that process and other resources. You can communicate quickly and effectively, but if one of your threads messes up, it could mess up everything else that's going on. Kara is subject to messing stuff up when we're fishing. It could mess up everything that's going on. Great. So what's the problem with this scenario? we still need more fish. A lot more fish. So I'm going to invite, we're going to kick Kara off the boat. I'm going to invite 2 more people. So that was threading, something like C or C++. Now we're going to talk about multiple processes. I'm going to invite my dad and my brother. My dad, pretty big guy, very classic, only going to fish with worms and bobber. He's going to bring all of his own stuff, his own worms, everything, his own gear. Nope, not that, not bringing his own. If that's a cooler, that's not what he's bringing. He would not bring his own beer. He'd rely on me, or whoever's boat it is, to bring the beer. And my brother, he's only going to fish with bobbers and his minnows, and we are going to catch a ton of fish. I'll relegate myself to just fishing with the net, because we're talking about just multiple processes. Make sense? So in this case, everyone totally clean, totally separate. One person focused on net fishing, one focused on fishing with the worm, one focused on fishing with the bobber and the minnow. There's no stepping on each other's toes. If I mess up my net, it's not going to hurt my brother. My dad brought his own worms. He's not going to use all mine, whatever. Very clean, very separate. What's the problem with this?
You can drink all the beer.
They're going to drink all the beer and eat all the sandwiches. This is just very expensive for the overall system when you start running multiple processes. Each has their own overhead, their own memory space. It's pretty expensive. But we're going to catch a ton of fish. Also going on here, they're taking up a lot of space in the boat, which is just, felt like that was a good part of the analogy. There's lots of idle time when I'm like swinging my net and just drifting back and forth, not catching anything. My dad and brother are literally just sitting there drinking beer and eating sandwiches. So we're not actually getting the benefits of a lot of the concurrency. We're just each separately running multiple processes. We have enough horsepower to do it, catching a lot of fish, but it's not the most efficient way that we could be doing this. Or it is a. There are other efficient options that we can try out.
Efficient.
Efficient. Yes.
Can we cut that from
All right. That was multiple processes. We have parallelism. Things are getting worked on at the exact same time, but we are not necessarily concurrent.
James, quick question, sorry. What's the difference between threading and C and multiple processes?
So in the threading in C, essentially the resources of the function that you've started are going to be shared across all of the threads. So the memory is much closer, you can communicate much easier, but if one thread messes things up, it could mess up the other stuff going on in that function. In multiple processes, it's like literally starting this process, then this process, then this process.
And there's more concurrency in that scenario because you're sharing all the same gear in this example.
In the threading example?
Yeah.
The analogy might not be perfect in that particular. It's close, but it might not be perfect in that particular case. It depends on like sort of how you're relating. In this piece, I'm saying that my brother's fishing has nothing to do with my fishing, so I'm not really going to call it concurrent. In the other case, I'm going to say that sure, Kara and I are all working the same rods, so maybe those are the same jobs, and therefore that's concurrent or related jobs.
Sorry, so if they're independent, they're separate processes for multiple, and then it's independent of each other, you said it's not necessarily concurrent?
I'm saying that the multiple processes are not concurrent because they're totally separate, they're totally different. This is like independent jobs in the same, with the same goal, something like that. It's a bit of a stretch.
Sure.
But let's talk about multiple processes with some concurrent programming model. So for this, I'm going to kick my brother and dad off the boat. You can keep the poles. Those would be useful. And then I'm going to invite my friend Nick. A lot of you guys have probably met Nick before. He's a very versatile fisherman. He's going to bring his own gear. He's going to bring 3 more poles. And we're going to set up in such a way that we are both each fishing 3 poles in this particular setup, or 2 poles in a net if you want to do that. All right, awesome. So basically, we're taking the gevent style analogy where I'm going to fish both the worm, the bobber, and the net, adding my friend Nick as another processor who's also going to fish a worm, a bobber, and his own net. And we are going to catch a ton of fish because we are operating both in parallel and concurrent. There's almost no downtime on this boat at any given time across our 6 lines. Somebody is catching something. We're not using that many system resources. Nick's like same size as me. I don't drink that much beer. Kind of lightweight. So is he. Like, it's not like my dad and brother are on this boat sitting there doing nothing but drinking beer and eating sandwiches. So it's efficient. It's pretty, lots of parallelism going on. He can be catching a fish on the bobber while I'm netting a fish. It's concurrent because my bobber is getting work done at the same time, not at the same time, sorry, while I could also be getting work done with my net. Make sense? What are the cons of this? It has all the cons of both multi-threading and multi-processing. Lots of stuff can go wrong in this case. We're going to drink a lot more beer than it would just be by myself. So it's probably relatively expensive and relatively complicated. But if you can get it right, you're going to catch a lot of fish with not much downtime. Same thing in programming. If you're running something like this, you can get it right, but there are lots of bugs, and it can be hard to debug them. This is actually what we did with eBay for a long time. We ran multiple gevent-based processes where each process was running multiple jobs at the same time. Cool, right? But we can still catch more fish. Yes, exactly. Exactly.
You're gonna need 2 rivers now.
Close, close. We're gonna call my brother-in-law John. John's a fantastic outdoorsman. Catches way more fish than me. Exactly. He's gonna bring his own boat and his brother Charlie, and we're gonna run roughly the same setup. And this is about multiple systems, which is what we do a ton of here. Yes, perfect. Perfect. This is the most efficient way to catch as many fish as possible in a given amount of time. That's not true. This is the highest variance of the amount of fish you can catch in any given amount of time. You could catch 0 attempting this. But this is basically as complicated as we can get. You have 4 processors across 2 different machines. Each processor is rotating between 3 different concurrent jobs. You have 12 fish catching contraptions in the water. You're consuming, only 4 processors worth of beer and sandwiches, which isn't that much more than we're doing in the multiple process area. You've got almost no downtime as fish are getting caught left and right.
And if a boat sinks, you still have 1 more.
What's that?
If when a boat sinks.
Exactly, yes. Yes. I've never encountered that in my fishing, which is why I didn't have this in our model. But yeah, if one of the boats sinks, ideally you have another boat that could still, bring home life-saving dinner, which is obviously the goal.
Could you think of the fish as a resource?
What's that?
Probably isn't helpful at all. Like, what if you add more boats and then there's less fish to catch, so you're less productive?
Would that be like
Less items, no items in the queue.
That'd be like a long-term thing, like serial overfishing of a fishery or something. That's why there's size limits on all the fish.
So question, would it be more efficient to have like specialized bots, like one bot with all the nets and one bot with all the, whatever you call it, so you could like basically run
I think that depends on your individual environment or individual problem that you're solving. On a lake, I would say no, because there's lots of different species of fish in a lake that you could catch, and each different species has different ways that it might prefer to be caught. You're never going to catch a bluegill on a giant minnow. They don't eat those things.
Yeah, but the next boat that's specialized will catch all of them.
Yeah, but maybe the bluegill are only in the spot that your current boat is. So I don't know. There's definitely situations where you want a super specialized system, which is the same thing you do in computer engineering. For us right now, we have lots of systems, lots of boats. Each boat might have lots of different rods, fishing styles, and nets in it. But in general, we have sort of this multiple processes system going on, where each process is really only focused on one type of job, one type of fishing that is going on. That's true on a process level, but not necessarily on like a whole system level. So each of our processes has a lot of weighting, but the system, the machine as a whole, is probably pretty efficient because at any given time it is actually working on one of our processes. Does that make sense? We don't do any threading or gevent work or anything like that within any of our particular processes at this point, I don't think. Any holes to poke? My analogy, anything I didn't cover?
Where does asynchronous fall on this scale? Like, I think a lot of us here learned to know that we were always like, the JavaScript's asynchronous, but I think the benefits are kind of lost on me. Or where that just falls in.
I don't know what the exact answer would be. I would say it's very similar to sort of the gevent model, where basically your processor is going to always try to keep special interruptions on that processor when a message comes back that was previously asynchronous. But the idea there is that if you think about lots of different paths that you can process on, when one request that's going to come back, it'll just switch to the next path and keep processing on that. Mm-hmm. When that request comes back, you go back and finish it.
I guess the analogy is that you can put like your worm in the water and you don't have to wait for a fish to bite to go to connect. So that would be the asynchronous analogy. You can do something else, and when a fish bites on the worm,
then you go back to that.
Go back, take that, and do whatever you want to do.
Yeah, most of the time, as worm to bite, you're receiving other people, like that.
So to extend this analogy even further.
Fantastic. I'm listening.
So, let's say every time you catch a fish, you have to like put it in a cooler. I don't know where you put it, and there's only one place where you can put it.
Yeah, exactly.
So then it's like a lock. It catches a fish, has to use a cooler.
The fish go bad if you don't get them in the cooler. It's pretty bigger cooler.
Another benefit of the multiple systems is that it's also very straightforward to scale, right? Like, we need to add 50% more to this. We're like, great, add or double it, like 2 more boats.
Yeah.
It's pretty like.
Yeah, in that world, I guess the lake would be our fleet as we consume all the fish.
Data. It's the data lake.
Is that where it's going? Hold up, it's just a giant thing that has the data lake? I didn't think about that. Really did.
Sorry.
We're going to redo this next week. Yes, this is entirely a setup so I can get to data lake. Oh, I can't believe I didn't do that. Those boats, if you want to.
You presented this as like an evolution from like the simplest thing to like the best.
No, it's the opposite, actually, in my personal opinion. It's from less like complexity, but I would argue that like, yeah, I don't think it's better necessarily.
Is there a reason you would like? It seems like if you have a large system that needs to process a lot of things, you would always want to do multiple systems. Is there still a reason why you?
It's just cost. It's more expensive sort of the further down you go in terms of resources that you're going to be consuming. The gevent or something like that, if you're running multiple functions, is strictly better if you have to pay for the CPU, even if it's being used or not being used, but you definitely pay for that in complexity. It's a more complicated way to program than just running single instances of a function or multiple functions. In our case, we are almost always bound by the network and all the efficiency benefits we had of running eBay through a gevent or multi-threaded type system just were not at all worth the pain of maintaining them or the complexity of explaining them to other people.
Did you originally set it up because it was before PipeApp, or
What's that?
when you originally set up the gevent on eBay, was it like before PipeApp, so that's why you were?
It was before PipeApp. I can't take credit for originally setting it up. And actually, I spent like 3 months trying to make it faster because I was convinced that if we just scrape faster, everything would be better. But that's not true. And then I spent the next like 9 months, actually we spent the next 4 years getting rid of it. Yeah, if you do have a system though where you know you're going to be where you're not going to be CPU bound and you want to get more work done, multi-threading can use the exact same resources you're going to use anyway and get more work done because it basically gets more things in the water and lets them sit there, and then it goes and reels in whatever shows up. Thanks. Special thanks to Andrew.
Thank you. That was awesome.
Cool. Yeah, that was helpful.